Hello, this lesson is all about linear momentum. Let's learn its definition, how to calculate it, and practice with an exercise. So by definition, linear momentum is the product of a system's mass multiplied by its velocity. Okay? We have also to know that momentum is a vector that has the same direction as the velocity. Okay? It makes sense because we're multiplying the velocity of vector by a scalar number, that's the mass, right? So we change the magnitude, but the direction is the same. Also, we have a relationship between momentum and the Newton's second law of motion. So we know that for a system, the net force is the mass times the acceleration. And the acceleration is actually the variation in velocity divided by the variation in time. We can just put this mass inside this multiplication here. So we have that mv is actually momentum. So it leads us that the net force is the variation in momentum over time. A property of momentum is that it's conserved. So linear momentum is always conserved for an isolated system. You can think about it like you have the net force, that's the variation momentum, divided by the variation time, and we know that for an isolated system this net force is actually zero, so the variation in momentum is also zero and it's a constant. So we can also think that if you sum up all the momentum of a system in a certain point in time, it needs to be the same as the summation of all the momentum in a second time. Okay? An easy way to visualize it is when you're playing snooker. Okay? So you have a system of two balls. The first one is moving in a certain velocity. The second one is not moving. Its velocity is zero at the first moment. When the first ball hits the other one, that's when the momentum is conserved. So the first ball transfers part of its momentum to the second ball, and it starts moving in a direction, okay? And the first ball reduces its velocity because, well, mass is constant, but we know that's a part of the momentum was transferred to the second ball, so the velocity of this one reduces, okay, and momentum is conserved. Okay, let's practice a little bit. So we have a car that's moving at 10 meters per second and crashes into a tree and stops in 0.26 seconds, okay? We want to calculate the force the seatbelt exerts on a passenger in the car to bring him to a halt. And we know the mass of this passenger is 70 kilograms, right? So let's apply the conservation of momentum. So we know that the variation in momentum here is the mass of the passenger in state 1 times the velocity at state 1 minus the mass in state 2 times the velocity at state 2. Well, the mass is constant and equals 70, right? So we have this change in velocity from state 1 to state 2. We also know that state 2 is the velocity is 0, right? Because the car crashes into a tree, so everything stops, right? We want the passenger to stop, the seatbelt to stop the passenger, right? So the velocity at stage 2 is 0. We know then that the variation in momentum is actually the m times v1. So it's 70 times 10, which is 700 kilograms meters per second. Okay? All Alright, now we can calculate the net force. So the net force in this case is the variation in momentum by the time. So you know that the variation in momentum is 700. It takes 0.26 seconds to stop. So the net force is actually 2,692 newtons. Okay? This is the force that the seatbelt exerts on the passenger, okay, in order for it to stop. Okay, so it's your turn now. Let's imagine the situation with the car, but now the same car with the passenger of 70 kilograms, instead of colliding with a tree, it collides with a car that has a mass equals to the first car, and it's traveling the opposite direction at the same speed. Okay, so the same car as before, instead of crashing into a tree, now crashes into another car with the same mass but in the opposite direction. Okay, and at the same speed. So thinking about the situation, would the answer to this question, this net force here, would it be different? Would the moment be different? Would the net force be different from the first case? What do you think? So think about it, do your calculations, and explain your answers in the comment sections.
Thanks for watching. Don't forget to subscribe and turn on notifications to always get the newest videos straight to your feed.